So now we can start to talk about sampling and aliasing. So before we do that, we have to talk about the notion of sampling at all and the notion and the idea of reconstruction. So here we have the idea of some nice smooth scene illuminated by a light source, and then we have an imaging system that captures the intensity at a bunch of discrete places. And of course, what we'd like to do is we'd like to take the captures from these discrete places and be able to reconstruct this nice smooth signal. That is, to know what that signal is. Let's talk a little bit about sampling. Sampling arises when we come up with this notion of how do you store a continuous signal in a computer, right? So here we have a continuous signal, and this is in 1D, and we're going to do a lot of our stuff in 1D today because it's easier to draw. And so the obvious way of representing that, it's actually not the only way, because you can imagine different clever basis kinds of things, but sort of a normal way of thinking about that is by samples. That is, you just take the samples at each different location and you write down what the value is. And once you have that set of samples, later what you want to do is reconstruct what the original signal was, right? And why do you want to do this? Well, maybe you actually want to use the signal. You want to play it, if this is audio, you want to play it through a speaker. And I don't need samples, I need a continuous voltage. Or maybe I want to do some sort of analysis or mathematical processing in terms of thinking about what this signal is. So essentially what you have to do is you have to guess what's going on between each of the samples. That's all you can do. You have the samples at discrete places, but you need to connect the dots, if you will. You need to fill in what's going on. And a lot of what we're going to talk about today has to do with what's actually going on when you think about taking a set of samples and then trying to guess what's in between. So to illustrate most of these points, we're going to use a 1D signal. So you can think of this like audio, all right? So here's an interesting audio signal. You see this signal? So this is time, okay? Goes this way. And it starts off with a low frequency and gets higher and higher and higher and higher and higher and stops. All right. If you were to play that sound, you would hear what's called a chirp. Okay, that's actually what it's called. It's called a chirp, comes from radar, et cetera, whatever. It's something that has power in lots of different frequencies. So when you send a chirp out, no matter what the frequency response of the thing you might be hitting is, you'll get something back. It's also a nice way of being able to localize it. There are lots of good reasons to use what's called a chirp. But here's a chirp that has higher and higher frequencies. But it's a good signal to think about looking at aliasing.